So, a really long title. But before we even get into it, I want to break down this title because it tells us a lot about this. So solving quadratics, usually what that means is we're trying to find a value of x, okay? And technically this isn't complete. It needs to be equal to something. So I'm assuming this question was equal to 0. Was that correct?
Yeah.
Yeah, okay. The second part of this, perfect square trinomials. Do you remember what those are off the top of your head? What that is?
No.
Okay. A perfect square trinomial is a really specific trinomial. And trinomial means there's 3 terms. So we can take a look right now. We can actually see there's 1, 2, 3 terms in this. So this is great, but it's not a perfect square trinomial at the moment. We need to do something to it. So we got to always keep in mind what the underlying form is for a perfect square trinomial. And they're written like this. A squared plus 2ab plus b squared. So we need something that replaces a, okay? And we actually have a squared value. That works out really nicely. So we can almost say check the first term we're okay with. We need our middle term here, okay, to be equal to the square root of a, the square root of b multiplied by 2. So we can actually build our own equation to figure out what we need this third term to be in this case. Okay, so if we think about it here, we know the square root of the very first. X squared, since x squared is our a term in this, if I take the square root of x squared, I end up with x. Well, the x is already part of it, so that works out really nice. So we've got the a's checked off. B is where we run into some trouble. Okay, we need the square root of b. And whatever that term is, okay, it needs to be multiplied by 2 to get this value. So essentially what we're left with is 2b is equal to whatever the coefficient is. Well, the coefficient in this case is 5. Okay, coefficient is 5. We got 2b. Well, what does that mean b is going to be equal to? Well, I can solve for b. What would I do to solve for b on this case? How would I isolate for b? Any ideas?
Yeah.
What would we do?
Oh, yeah. No, I don't, actually.
Okay. Since b is times 2, we just need to divide both sides by 2. Okay? So we get b is equal to 5 over 2. So 5 over 2, that actually needs to be what our b term is here. Okay? B needs to be 5 over 2. And then to find out what this actual final value has to be, so this is one that's dealing with fractions. It's a little more complicated. We need to figure out what 5 over 2 squared is. That's what this final term is going to be because it's technically b squared. So b squared is 5 over 2 squared. 5 over 2 squared is going to give us 25 over 4. So this equation can still be written as x squared plus 5x. It's this term here, the 7. We need to do something over here. We need to do something with this 7. We need to turn it into 25 over 4. Okay, maybe I'll write that in blue so it's a little clearer. So this is a complex question because we didn't work with nice whole numbers.
Okay.
So the question is 7 plus what, and you can use a variable to represent it, is equal to 25 over 4. It's dragging a lot right now. How can I find that out, Nathan? What is the number I need to add to 7 to turn it into 25 over 4? How can I do that process? Maybe we'll jump to another page for that part because that part could be tricky in itself. 5 plus something is equal to 25.
25 over 4?
Yeah.
You said?
Mm-hmm.
1 sec.
Yeah. You evaluated that and you figured out that by bringing 7 to the other side, it becomes negative 7 plus 6.25. You decided that the missing value here is negative 0.25. So let's go back to that other page. That's the value we're going to need to add to both sides of our equation to create a perfect square trinomial when we have a question that's not really nice numbers for us. So we have our x squared plus 5x plus 7 plus negative 0.25. So we're just going to say subtract negative 0.25. And on the other side of the equation, we're going to have negative 0.25. Okay? When we put that question in, we get to a point here, and what's really important as we go through this, x squared plus 5x. I'm just going to jump up and back for a second. Fix the This is going to be positive 6.25. This makes our perfect square trinomial, which means we end up square rooting and getting a value that's squared. This is really important for our solve here. When we square root this, it actually ends up being, I think, 5 over 2. So I'll leave it as a fraction. That's why that fraction is actually helpful. But what's important here is we have a negative value, which means there are no x-intercepts. So when we were to go to solve this, this is some quadratic that is either opening up where the vertex is above or opening downwards when the vertex is below. Okay, so we've gone into a pretty, not unique because it's possible, but we've gone into a scenario that is we're unable to solve it through this method, and technically any method.